Welcome back, everybody. And we should be looking at activity 4 now. Making sure we have audio. Okay. This will be a short one. It's got a chemical. It's got a chemical that we've used before. NABH4, you want a reminder of what that was? This is extra over here. I do not need extra as part of your activities. If I put like boxes to the side, it's extra. I know that's an expression your generation likes to use now for people, but we won't get into that. Okay. NABH4 did this in the old days. R attached to a mercury OAC went to R attached to H when you used NABH4. I'm believing that was in chapter 6.1. Question mark, is this an F? G, I don't know. It's the oxymercuration, demercuration. So if the section number doesn't match, that's not how you spell mercury, Dr. Whitaker. Okay. There you go. It's the demercuration after the oxymercuration. Okay. Mercury. Okay, that's not what we're using it for here, clearly.
So I need to get a job, to have more experiences.
Somebody's having their day's activities.
So I can, if I ever travel or move abroad, I can set up a job.
I don't know what to do with that. Okay. That's in the video. So I think. Okay. What is going to happen here? Okay, we didn't do a mechanism for the demercuration, and we never will. This is more typical of what sodium borohydride does. Its name kind of gives you a hint. What does IDE mean in a two-word name of nomenclature? IDE in a two-word name like sodium chloride. What does chloride mean? Cl minus. Hydride. What does that mean? Hydrogen minus. I do not see a hydrogen minus. This molecule behaves as if it is a hydrogen minus. You must first make hydrogen minus for this reaction to proceed. Remember, hydrogen is more electronegative than boron. So get yourself into a molecular level. You are now molecule size. You are thinking like a molecule. You are BH4 negative. Yes, this is BH4 negative. Hydrogen is saying, hey, boron, did you forget I'm more electronegative than you? How dare you have a minus charge with me here? That's basically what's going on. And here's the action as a result of that threat. Hydrogen's threatening boron right now. Says you don't belong. You don't deserve a minus charge. I pull on electrons more strongly than you. I'm taking my electrons. I am becoming what my name implies. What did the name imply? Hydride. That is hydride. Want me to type it? That is not your normal ion of hydrogen. Thank you very much. All right. Hydride, the ones you've seen before, like KH, is a strong base. This hydride does not behave like a strong base. It behaves like a strong nucleophile. It doesn't want to take a proton. It wants to attack something that feels positive. What in cyclopentanone feels positive? The carbon with 2 bonds to the more electronegative oxygen. Make it happen. Attack the carbon, resonate to the O. Do not try to combine this in 2 steps. You're not allowed. I will talk more on that shortly. You've got an O that has a lone pair and a minus. You got a new H. Really don't have to show it, but it's here. Then step 2. O minus reacts with H in HCl. If you tried to combine this and said, I'm going to do the red first, and then have a lone pair on this O attack this H, you're fired. The last person that mixed sodium borohydride with HCl is no longer with us. You can't have them together in the same reaction. They react violently and create a very powerful explosion. You must finish the first step, wait for it to be finished. In the lab, you test to make sure it's finished, and then you add HCl. Your mechanism must reflect that. These 2 species are not together. And I know I said it was going to be short, but it wasn't as short as I thought. We're done. Don't need all this extra stuff here. So that is one of our easier mechanisms, isn't it? We like easy mechanisms. So I'm going to give you 10 seconds. This is time for a screenshot if you need to. I'll be creating activity 4 at at Moodle, sorry. And I think our 10 seconds is up. I'll see you for activity 5 shortly.